take them down, take them down and take them down and take them down. As you look, the whole room explodes down and as you look, the whole room explodes down and
Yeah, so I was told that most of the audience would have experience with Git. So I wasn't sure exactly how much experience. I wasn't sure what things you would know, what things you wouldn't know. So I really just picked a bunch of things that I really enjoy. And I'm going to talk about them. And I'm here to answer any questions, or if you guys have like a specific workflow that you use and you're curious how any of these features fit in, feel free to stop me anytime. This is definitely meant to be interactive. Like, take out your laptops. We've got a repository that we can mess with and play with and try to make crazy things happen. But this is definitely like a back and forth thing. Like, you guys got to talk to me just as much as I'm going to talk to you. But let me start with who I am. I am Skalnik everywhere on the internet. My first name is Mike. That's my last name. But on GitHub, Twitter, whatever. And you can usually see me wearing a sombrero in most of my pictures. And like I said, I'm going to talk about a few of my favorite things that Git does. And we're going to start out with, just resolving a merge conflict. So I actually have a gist. Apparently all of my notes are gone. But there is a gist that just runs through some basic Git commands and writes out, it forces a merge conflict. So if we make this bigger, or actually let's view this on my computer so you can read it properly instead of a broken web page. So this just makes a directory called merge conflict because that's exactly what we're going to try to make here. It initializes a Git repository. We have a small text file called greeting.txt. We add that file in there, we make our commit, and then we check out a different branch. So a merge conflict is almost always going to happen when you have two branches that you're merging together. Or, master is somewhere other than your master. So you have to merge two things to actually get a merge conflict. So we're going to check out another branch and we're going to call it conflict because that's what we're going for. And in our branch, we change that one single text file. And then back on master, we change the same line. So because these branches both modify the exact same line, when we run the merge and we try to do git merge the branch conflict and we merge conflict branch into master, it's going to yell at us. So here we can go ahead and run through these commands ourselves. So I'm going to make that directory merge conflict and go into it. So right now nothing's there. There's no Git repository, there's no files, there's no nothing. So let's see. It was yay DevconTLV. And so we'll just put that in greeting.txt. And actually we're in a Git repository, so let's get out of that. Let's go to the my temp directory. So in this directory, there's no Git repository just yet, so we can start that one up real quick. And we'll add all the files in it. Right now, it's just that greeting.txt, but it's all we need. And we'll make our first commit. So if you do -m, you can just specify the message right there. Or if you leave it off, it'll prompt us for something. So we'll just say, it's our initial commit. Or commit. And so we have that single commit on our master branch. I'll go ahead and check out that other branch. So here we're going to change that one line in there to, what did we have in there initially? So yay. Let's write woo instead. So a pretty simple change, but it'll get us what we need. So we'll commit that to. No, I'll stand for a little bit. But I forgot to add the file. If you do git dash a or git commit dash a, it'll actually include any of the files it's already tracking. It'll automatically commit those together. So if I do dash am, it sees that I've changed greeting.txt. It'll include that and give us a message that I've specified. We'll go back to our master branch. And let's move our celebration to after DevCon. DevCon, yay. And now when we try to merge this branch in, this conflict branch, Git's going to yell at us. Or if I commit it first, at least. Here, I'm going to sit down right here. So now that we have both of those changes on those two different branches touching that same exact line, when we merge it, Git's going to yell at us. And I don't know, I've actually heard of some people, they get this warning and they're like, I can't do it, it's over, I'm going to delete all of my files and start over again. And I talked to one guy and he was telling me how he's lost days of work because of this kind of stuff. But it's really easy to fix. Git actually is telling you all the things you need to know right here. If I don't close my tabs. So let me move this back up. But so it yelled at us, and now if we look at this greeting file, it's in a specific state where this is not, like we've written those two lines, but Git's added this extra information for us. And it's telling us something broke, like these two lines were both touched by, in these two branches, and I don't know what to do with them. I cannot figure out by myself what to do. So human, please come here and help me figure this out. So if we open that in a text editor, really all we need to do is combine these lines and whatever makes sense for us. So let's move our celebration to the end and change it from yay to woo. And we're done. We've resolved our conflict. Now that we've done it for our own text file, that's pretty awesome, but we need to tell Git about it too. So all we have to do for that is just do git add that file, and then we have to commit it. So we add that file.
Can I ask a question?
Yeah, go for it.
How come you should instruct it about that you resolve the conflict, because it can see that there are no signs?
So Git's not always running. Git is only runs when you actually tell it something. So it doesn't automatically see that file has changed. So we have to tell Git, we have resolved the conflict. Let us make that merge commit that we were trying to do before. So now it's like, okay, well you're doing that merge that you were trying to do before, and it automatically says, hey, there was a conflict in this file, and annotates it for us. So people down the line will say, oh, well, they did this commit and there was a conflict, and then they might say, oh, well, maybe Skalnik did not resolve this conflict properly later down the line. But because it automatically annotates it for us, they would kind of know. And you can change this message if you want, but I usually leave them as is. And then we can see, if we look at our log, that all of our commits are there, and our one conflict is resolved and committed, and it's all good. Cool. So hope that you guys kind of was hoping that a lot of you would know about merge conflicts, so hopefully you guys all followed along pretty easily there. But scary red text, not so scary, easy to deal with. We handled it no problem. Now, merge conflicts are kind of a pain, especially if you have to deal with them a lot. So there's a really awesome feature that Git has called re. And I don't know exactly why it's called this. I'm sure there's some really clever reason, and it's documented in the man page. But I'm not entirely certain off the top of my head. But it remembers how you've solved a merge conflict. So if we were to run into that same kind of problem again, Git would remember, like, oh, okay, so he changed yay to woo and put it at the end. Like, that's what we did. But it's for some reason not enabled by default. So first you have to run your configuration and enable it. And you want it to be a global thing. I mean, you can make it per project if you'd like. I actually usually enable it globally and just have it always there.
Can I ask a question?
Yeah.
Why would you have a recurring merge? Like, what patterns is it recognize?
I'm about to talk about that right now. Perfect timing. So, exactly, why would you be getting this kind of exactly the same merge conflict over and over again? So a common pattern is to have a topic branch. So you have your master branch sitting there, and you're working on some feature off to the side. And it's pretty cool. It's coming along, but there's been a lot of changes on master from where you started your branch. So here we can see, master has 2 commits on it, and our topic branch does 2. And those 2 highlighted commits touch the same exact lines in a file. So, as our topic branch keeps going, we still want to do more work, but we want to merge master in so we can get the changes that have happened there. So we'll merge in master, and we'll resolve the conflict ourselves, and everything is fine. And we'll keep working on it. And if it's a long-lived topic branch, we might want to merge master in a few times because master keeps changing, and so does our topic branch. So we'll keep merging master into our topic branch. But then you have this branch that has maybe 10 commits, and it might have like 5 merge commits as well from master. And some people don't care about this, other people do. There's actually, if any of you follow the Linux kernel mailing list, there was a very good example of this where Linus was asked to merge in a topic branch from a subsystem maintainer. And Linus was like, no, fuck off. This is filled with like all these merges. I don't want it. Like delete all those or get rid of those commits that have all these merges and give me something that's a little bit cleaner. So if you're making these merges, you can remove them as you're doing them. So you can merge in master and be like, okay, cool, everything is still working out. Or you could use rebase. That's another. I'm going to talk about rebasing as well. But some people. At GitHub, we don't ever use rebase. We really like merging, but we also don't care about having a bunch of merge commits. So, I mean, there's a bunch. I like to think, I heard one good quote, Git isn't necessarily a version control. It's a tool that lets you construct your own version control system. Like the amount of workflows around Git are numerous, so you can figure out your own kind of way through it. But this is how they were working on the Linux kernel, so I don't know, have at it. So let's say we did a proper thing, we cleaned out, we removed that merge commit, we had some other commit in its place. It's all good, our history looks nice and clean. And then we want to merge master back in. Well, we're going to have that same merge conflict. And that's where this command would be very helpful. Now, once you've enabled it, it would see that you're merging, and it sees the exact same merge conflict, so it would just automatically take care of it for you. And you wouldn't have to worry about it. So it's a kind of a feature that I leave on all the time, and sometimes randomly helps me out. I don't even think about it, even remember it sometimes.
It can also be a dangerous thing, that it resolves the conflict not in the typical way that you would.
Yeah, so exactly. I'm pretty sure that's why it's not enabled by default, because it's something that if you don't know what's going on, it could be a bad thing. Like I said, I usually have it enabled and haven't had any problems, but maybe I haven't even realized it, right? Like it's bitten me down the line and I haven't known. But it's a pretty awesome feature, especially if you have this kind of workflow. I mean, I don't necessarily have this kind of workflow anymore. I did in the past. I know I had some crazy topic branch and was asked to rebase it on something, and I just kept hitting the same exact merge conflicts over and over. And that's when I found re and was like, this is the greatest thing in the world. So, yeah, what's up?
So if you remove the merge, the middle merge,
Yeah.
then where is the information kept for this re? It's not in
So,
any commit.
Git, actually, that's a good question. I'm not entirely certain where Git keeps that information about that merge conflict. It's probably somewhere in the .git directory, and I bet you if you blew away your .git directory, it would not be able to remember that commit. Now, where exactly in .git, I'm not entirely certain. We can try it out if you want, if you're really curious. We'll have to make some stuff up to get this kind of thing. Let's see. So we've had that one merge conflict. Actually, this would probably be a good time. So I made a simple repository. Let's see if I can get internet. And I'll close all these other tabs. So I don't know if we'll actually be able to use GitHub.
I'm connected to the OZen network and it seems fast and unlocked.
Right on. Let's see if that helps us out.
Or you can tether with mine.
Cool. This is working pretty well. The OZen network. So this isn't a public repository for a simple GitHub page. So if you go to actually devcontlv.github.com, you get a little page, and I've made myself a small profile. So I'd encourage you guys to go in there and issue some pull requests, and we'll definitely get some merge conflicts and stuff like that happening there. And if you want to take the time to make a topic branch and merge master in a few times, then we can. Oh, you don't have a computer. I can help you out with that then. But let's keep going, and then if we have time at the end, we can start digging into the .git.
DevconTLV?
Yeah.
DevconTLV.
What's the stuff you have on top?
So that's our staff bar, and that tells us just like we use it for timing. You know, I can see how fast it was necessarily responding, stuff like that.
It's not public.
No, that's not a public thing. You guys get to see the secrets. And it's like, you know, what branch is deployed, what SHA. We have a custom server just for GitHub employees where we can test other random things too, so I can switch to that. Stuff like that. But yeah, it's a staff, like a staff bar. But yeah, so I'll just keep going through random stuff, and we'll hit those merge conflicts and stuff like that. So I would encourage you guys to do some pull requests, and then we can, you know, see some interesting things happen like that. But as you were saying, we could also use Rebase and not have those merge bubbles in there. Rebase is a very interesting thing. It is very much not a merge, but it's some preparation for a merge. So it reorders some commits, and it's a very dangerous thing because it rewrites all of those SHAs. So your history will change dramatically with a Rebase. Instead of having these two branches side by side in your history, it'll move it so you have them in one giant line. Now, one of my favorite things to do with rebasing is using interactive ones. So if I notice that I've done some crazy things in my commit history and I haven't pushed it anywhere yet, it's really awesome to use an interactive rebase. And there I can, you know, take commits and squash them together, or go and amend it, change a few features, things like that. And so this will take, you know, the last 5 commits of a thing, and we can rebase interactively on it. So we can actually check this out with this merge conflict thing. And we don't have 5 commits, but I think we have 3. And -I is a shortcut for it. And maybe I have my syntax wrong here. Or I don't have enough commits. So you can also, yeah, I don't have enough commits for this, that's why. But if you do just a SHA, you can also go backwards that way. Although I'm in the middle of a rebase, so Git's gonna yell at me. It says you're doing it already, so you know, go ahead and finish that one. So we'll abort that first one. And so here we see, you know, our 2 commits and some commands at the bottom. These are all commented out, but it, you know, kind of tells you what kind of things you can do. So everything right now is just picked, so that means everything is going to be just as it was, but we can do things like, you know, squash 2 commits together, like this is saying. So if we wanted these to be one tiny thing, one commit by itself, we could do that. Or if we just want to stop at that commit and change it a little bit, so we can go ahead and edit this commit. And once you save this file and quit out, Git will start going through this process. So we don't have too much history to play with right now, but cool. So it says, all right, you've gotten here. Now, once you have continue, or once you want to continue, you run git rebase -continue. Or if you're like in the middle of it and you actually realize you don't want to edit it anymore, you can also skip. And lastly, it says, you know, if you're in the middle of this and you realize you have like tremendously messed things up, you can also get out of it completely, which is what we did before when you abort it. But if we look, we are right now on this one SHA, and we can do things like edit that actual file. So instead of DevconTLV, we can just say, you know, yay, and continue our rebase. Now I think it might yell at me because I did not commit, but we'll find out. Yeah, so it says, you know, this, you know, you're in the middle of this rebase and you said you were going to change this, but you haven't committed yet. So if we do a git status, it says, okay, this was, you know, that was a merge right there. So you need to go ahead and add this file. We can add it and be along our way. And now we can see, you know, our history is going to stay the same, but these numbers have changed. And if we look at that actual change, we see, you know, our commit that we changed right there has changed exactly how we wanted it to. So interactive rebases can be useful when you've kind of fouled up your history and you want to make something better out of it. Do you guys have any ideas when this could be useful? Like,
Well, it's useful.
yeah?
For me, I use it when I work on a local branch, and I keep pulling changes from an upstream branch, and then I don't want to merge them, so I don't want to end up with little merge commits.
Yeah.
So I just, if it's a local branch, there's no worry about rewriting history, so I can just plug that branch and put it on top of my my upstream
Yeah.
branch.
Perfect.
So this keeps it streamlined. I don't necessarily use it to squash commits because I typically, you know, I do smaller commits because I want them to be small. Don't necessarily want to squash them, but it is useful when, again, this works only when there's no history to be worried about.
Right. Once you push this up, like then rebasing is
Yeah.
rebasing becomes scary because you start rewriting all that history, and anyone else that touches that, they'll have to reclone and delete all their stuff and stuff like that.
Absolutely. So if it's a local branch, this is why I usually do it. I work on a local branch, then some more work gets done on another, on my main, on my master, let's say. So
Yeah,
just
perfect.
After I pull the master, I just rebase my work on top of master and continue.
Cool.
Done to keep merging it.
So one of the reasons like I've squashed commits together is sometimes I'll make a commit and then I'll realize that I actually wanted another change in there, but I forgot to add it in. And I realized this, you know, much later. And I'm like, oh, I should have done it, you know, together right there. So an interactive rebase is really nice because I can be like, okay, well, I'm going to move this commit from wherever it was to right before it, and I'm going to squash those two together. Now, one really cool shortcut that Git has for this is called auto squashing. Here I talk about all the things you can do with interactive rebase. So, you know, you can remove commits, you can take them out, reorder them, and put it back in. Now, when you do put these back in, while these SHAs might, you know, change a little bit, anytime you change a parent, all of the children are going to change because that parent, like, those are linked down, and that's part of the thing that gets hashed into your SHA. So anytime you change the parent, the child is going to change. So, like, we can see E69 turns into 41A, and that's because, you know, the commit before it changed. So it's going to change a little bit. You can also, like I said, squash. And for things like I was saying, when I find that I realize I want some change in something else, squash isn't necessarily the best choice because then it stops me and it's like, hey, what do you want your commit message to be? And I'm like, well, I know the second one is useless. I don't really need it. So it has an idea of calling these things called fix-ups, where you can fix up another commit, and then it doesn't even ask you for the commit message. It's just like, well, we're going to keep the first one. And this auto squash feature that I was talking about, if you actually start your commitment, like you are in the middle of, you know, writing your code and then you realize, oh man, this change should have been there. If you just name your commit message fix up with a exclamation point and then part of the message of another commit, and then you run rebase-i with this auto squash attached to it, it will automatically set those commands as you've told it to. So let's see here. So we can amend our commits as well. And I'm going to change this message. So hold on. We're going to say we want to fix it up with this. We want to squash these two together. So if I do git commit amend, it'll open up my last commit again. So I could also, add things and then do git commit dash amend, and I can add other files. But for now, we're just going to change the message. And we're going to replace it with fix up and that commit message. So this is just telling Git, when we run that auto squash, this is going to be a fix up, and it's going to be for this other commit that has that message. And let me look up the SHA of our initial commit again, so we can rebase onto it. And see, it's automatically said, oh, well, this was supposed to be a fix-up. So it automatically does it for us. We don't have to necessarily go through and change, what actual commits we want to be fix-up or squashes or anything like that. This works for only fix-up and squash as far as I know. I don't think you can do edit or reword like this. But, those are the two main cases where you would want it anyway. So it makes sense. And then when we save this, we can see now we have only this one commit that has all of those changes. And we can look at it and see what happened. So, do you guys ever use git stash? Yeah? Stash is a pretty awesome feature. I like, one of the really cool descriptions I've heard of it is that it's a really quick branch, even quicker than a normal one, just because it's easy to convert into one. But I've always pictured it as a place like a temporary thing that I can shove, a random commit into.
IntelliJ had this feature before I was introduced to Git. We call it shell.
Okay, Git shell. Yeah. Cool. So it is local only. You can't really push your stash up to anything remote, but it's pretty handy, especially when you have you're trying to merge something in, you have some changes, and you don't have a clean working directory. And this stash is stack-based, so you push things onto the stack, or you push things onto the stash and you pop them off. And you can also peek at the stash. And so if you want to stash some changes, you run git stash, and then you can save that stash with a certain message. So this is basically like giving it a commit message. You can look at all the stashes you might have. Like I said, you can pop them off. And if you want a very specific one, so it's stack-based, but you don't necessarily have to use it solely like a stack. So you can pop off just, one specific thing in your stash, which is nice. And if you want to keep it in your stash, you can also just apply it. And so that'll take the diff, apply it to your working directory, and still leave it in your stash so you can use it later if you really want.
In the previous slide, the number is just the index from the top of the...
So if you do so let's put some stuff into stash. Do we have any of those echoes lying around here? Yes. Oh, I guess that's the one we already did. Yeah, we can make another file. We can do, I don't know, random things. So now if we look around, since Scary isn't in our Git repository just yet, I don't think that'll get stashed. Oh, no local changes. I thought...
Can add it.
Yeah, so we can add Scary there. And we'll commit it. So I have some aliases that are pretty handy. So CI is for commit. So I don't want to confuse you guys, but it's easier than typing commit each time for myself.
You should use autocomplete.
Autocomplete also works, but I can also just type CI. I don't know. Some people have the habit of hitting tab. I have the habit of just typing CI. So now if we, echo something else into Scary, we have some changes. And if we do a git stash, those will go into the stash, and our working directory is clean. And we will look at git stash list. It'll show us, stash at, and those are where those numbers come from. So we have each of those, and we can apply them as we want.
Now, what happens when it try to pop the stash and you have a local modification of that file?
I don't know. Let's find out.
The problem with Smart,
That's a
I have no idea
You have
how
a
to resolve
conflict.
Yeah, you'll get a merge conflict.
it. I will get a merge. It will
Yeah.
complain that it's
So let's see what happens. Yeah. So you get a.
yeah. This what it says. And what would you usually do? You would either commit and then pop.
Oh, so no, this isn't a merge conflict. This is it's saying that it's going to change that actual file. It's going to overwrite it.
Yeah.
But it's not put in this merge.
No, it's not put in the merge conflict state.
Because
So-
you can merge them theoretically because
Yeah,
you have a conflict. but
that's
it
true.
doesn't know what to do.
So I mean, and now it's kind of, you know, you're in the situation of Git's told you your two kind of options. You can like remove that file, or you can commit your changes, or you could stash it and then apply the
Can I
previous.
apply to a current stash?
I don't know if you could like put the two stashes together. I don't think you could, but you could stash this, and then when you do your stash list, you can take the previous one and do, you know, git stash pop. Or actually, that's gonna do what I didn't want, but if you did git stash pop with that number, then it would just take that one out of the stash instead of the one that you had just put in. And then you can pop the next one as well. But I don't know, I don't use.
Right now it popped it and now it's modified again, so you wouldn't be able to pop the.
Alright, so this isn't gonna work. Oh, well, so this stash modifies something else, but. Yeah, so we're gonna get the same kind of message again. So you would have to at some point commit or remove your changes.
Right.
And then I guess you could squash those commits together if you're really worried about having two commits.
Why would somebody be worried about having two commits?
Some people really care about what their Git history looks like. Other people don't. I don't know, like I said, you know, it's work. Everyone has different kind of workflows around how they use Git. I know in the past, like I wanted to squash two commits together because I did something really dumb, and then I'm like, I don't want to have people see this just yet. So I hadn't pushed it anywhere. So I was like, okay, well I can do another commit, squash them together, and that way I look like a genius, and I'd make no mistakes ever. So
You could amend.
I could have amended, but you know,
Faster and easier.
different workflows for
I mean,
different.
amending like, I forgot this one, and this one, and this one, and if I have
Yeah.
amends.
That's true, but it also depends. Like if you've done commits after that, then you know an amend is not so easy. You would have to like rebase to there and then do an edit or something. Where if you could just do a fix up or a squash or something, that's going to be easier for you. And like I said, if it's too good to just stash, you can actually do git stash branch and turn that one part of your stash into a branch and start using it as another thing. So, you know, sometimes it's just for temporary usage, but sometimes you actually want a thing to be useful, and you realize that you've stashed something that's pretty handy. So another pretty awesome, but this is a very simple feature, is cherry picking. If you have, you know, your master branch and you see a commit in another branch that you really want, but you don't want the whole thing, you just want this one commit, you can use cherry pick to take that one commit and put it onto your master branch, or you know, whatever branch you're on. But it's a great way of grabbing just a single diff and pulling it into whatever you're working on. So I've used this in the past where I've had some project and I have this one commit or these small group of commits, because you can actually use multiple SHAs here. I just put one, but if you were to link, you know, or put like 3 or 4 SHAs in there, you could commit, or you could cherry pick all of them at the same time. But I have like, you know, some popular Ruby gem, and they've added a bunch of stuff that now has broken whatever I was trying to do. And I have this one feature I want to add. So I want to still use an old version, but I want to add some changes. So I can check out that version, cherry pick, you know, the commits that I do want from, you know, the later version, cherry pick my own changes on top of it. Then I have some crazy weird version, but it works for me, so I don't really care, and I can keep using it. And if you,
Push what you have done.
well, so I would usually fork the project at that point, and I would push it somewhere else. But I mean, you know, if that's what I need, then that's what I'm going to do. Depends on how much I care about, you know, contributing back to a project, or like yelling at the maintainer, versus how much I want to fork my own project, or how much I just want to get work done that day. Like, if I don't want to deal with those politics, I'll fork it, do my own thing, make sure this crazy idea I have actually will work, and then maybe go argue with the maintainer and get my changes in there. But yeah, cherry pick's a super simple one that is pretty awesome. I was kind of scared of it at first, but then I don't know, once I heard the name cherry pick, I was like, I think it just does this, and I used it and was like, oh, this is exactly what I thought it did. So that worked out pretty well. Another really awesome tool that I think not enough people know about is the RefLog. So Git actually keeps a journal of everything you do locally. You can see all of the things you've done. So if you do something crazy and you're like, oh my god, I've completely broken Git, I don't know what I'm doing. I have done this multiple times. There's no shame in it. Git is a crazy thing. It's big and complex sometimes. So I don't know. I've definitely hit points where I'm just like, I don't know. I've completely broken everything.
For instance, something you normally do, you hard reset to one of the previous commits and then you lose.
Yeah, yes, exactly. Like I've reset and lost information and stuff like that. So if you run git reflog, reflog is one word. So when I first saw it, I thought it was actually reflog, and I was really confused. I was like, why are you flogging people? This is strange. But
why are you flogging again?
Yeah. But once I found out it's reflog, things started to make more sense. So if you run it, you'll get some history like this, and you can see, we have head at 8 doing a cherry pick. There's an interactive rebase at head at 7. There's a lot of crazy things that have happened, and you can at any point, reset back to one of these, and that way you are in the Git history exactly where you were at that point. So that way you can kind of, like, if you've completely screwed things up, you can be like, okay, well, I've rebased and like deleted some commits I needed. You can use the reflog to kind of recover them pretty quickly. So let's just take a look at, the reflog for our merge conflict thing. So we've already, done a good little bit of history, a little bit of work. Say these squashes were not so great. So let's go back to before we even did the proper rebase. So we even see like our aborted rebase. I guess you can't see my highlighting on the screen too well. But yeah, if I highlight the whole line, you can kind of see it. So like you can even see that I aborted a rebase. It's like you started one, you quit, but it still keeps a history of it. So let's go back to this one right after we aborted that commit. And we'll use git reset for this. And reset is a kind of weird thing because it, depending on these flags, which I've noted down here, it'll do different things, and Git doesn't have the greatest API. So, some things can be kind of confusing. Reset is one of them. So it has, hard, soft, and mixed. Mixed is default, and that only resets our index. So the index is like the staging area of Git. So it'll reset the index, but it won't reset your working copy. But right now we want everything to be reset. So -hard will reset head, working copy, and index. So if we really screwed up badly and we need to go back to where that was, we can reset hard and go to that. And now if we look at our history, it's back to where we were before we even had that other rebase or that merge or anything, which is perfect. This is what we needed. We've saved our data, whatever it may be. Luckily, this project doesn't matter too much, but on more important projects, it's definitely useful.
I have a question.
Yeah, what's up?
Actually, you can use data only if you do not commit it. If you did make a commit and then you went crazy and you overridden your data, then it can be lost. But if you made a commit, because that's what the point I'm making.
Oh yeah. If you, okay, so that's,
commit, then go
yes, most definitely. If Git doesn't know about your changes and you've lost them, you're out of luck. If you have to tell Git about it. So you have to add the files to Git, you have to make commits.
Then start experimenting with
Yeah, exactly. It's completely true. Good point. You have to, if you don't commit it, Git doesn't know about it, and you can't even recover with a reflog or anything.
Yeah. Also, though, you have to do the recovery as soon as possible because reflog gets garbage collected.
Yeah. So, do you know how often the garbage collection runs? Once a month. Yeah. So I mean, I don't know. Reflog has been kind of a thing that I've gotten really quickly. Like, I've realized I've done something and immediately been like, oh no, this is completely wrong, no good. But,
Also for hard reset.
Yeah. Yeah, so I mean, if we look at our reflog now, we'll see those resets. So we can even, you know, even though we've reset, we can even go before that too, which is nice. Like even if we were like, okay, well, that reset was a bad idea, we can go back to edit 2. And there, now we've recovered, you know, exactly where we used to be, which works out very well. So this is actually one of the first things I learned about Git, and that made me immediately start loving it. Like I think 2 years ago or so, I wrote a blog post about this that I ended up finding again when I was Googling around for more information about this, which was really cool to see. But Git has this idea, like it can see the changes you have in specific sections. So, I mean, you know about adding a file and removing a file, but when you add this -- patch, it'll prompt you for every part of a file you have changed. So this will look something like this. It'll prompt you. It'll be like, hey, you changed, you know, app.coffee, and you changed these lines. Now you might have changed more in this file, but do you want to like put this specific section into your staging index? Definitely, like, blew my mind when I discovered it. Yeah, just a few lines out of what you might have changed. And this, I mean, this worked really well for me because I'm the kind of person that usually I'll sit down and for just, you know, an hour knock out a bunch of code, and then once it all starts working and I'm like, okay, cool, all of these things look like they're in the right place, then I'll start making commits. And I might make, you know, 5 commits in, you know, a few minutes, but I've, you know, made these changes over a few hours, and I want, you know, nice individual commits. So if a person has a problem with one, you know, they can reset a single commit or something like that. But I don't want to make just one giant commit of anything, but this way, you know, I can still keep my workflow of, you know, just sit down and work for an hour, not worry about commits, and then still have nice commit history on the other end. And
it's interesting because previously we discussed how to merge several commits into one.
Yeah. So I don't know. There's, like I said, multiple workflows. So I mean, I've worked at places other than GitHub that do completely different workflows, and we've still used Git, and it's still worked out. So.
Right. This is very similar to, I don't know if you've seen this still. The source tree.
I haven't.
It's a GUI for Git.
Okay, cool. Oh, awesome. And, yeah, I know like GitHub for Mac does it. I don't use the GUI tools at all. I believe it. Our GitHub for Mac is I don't know. It's sad that our Windows app is better for a, you know, a company that uses almost all Macs, but right now our Mac app is lagging behind our Windows app.
So they are showing you all of your changes like this.
Yeah,
by hunks.
That's pretty rad. I can dig it. I really like it. But yeah.
What happens when you do all but one? So what happens with one last?
So that'll stay in your working directory. So it'll pretend like, you know, you've just made that change.
So it will create another commit with just this change?
If you say so.
So I mean, at that point, it's back up to you. So it'll stage the things you've said. So if I were to say yes for this, that would be part of the staging thing. So it'd be like I added that section, and then in my working directory, the rest of the changed file would still be there, but it wouldn't be committed or anything like that. And another thing, so sometimes Git will, you know, try to be smart and it'll group a bunch of hunks together. That's not so great. So, you know, you can do things like split it with S, or you can even edit it. Like as you're sitting there and adding this file, you're like, oh man, I made a typo. You can really quickly hit E and it'll pop you into a text editor, and you can edit that actual diff right there. So you would get a text editor that looks much like this, except it would just be these highlighted lines, maybe some context above and below it, and you could change it real quick if you really wanted. So I've used this because, like, you know, I've made some changes and then the diff is too complicated for Git to get something nice out of. So I'll go and change the diff myself, and you get really, really fine grained control of what you're actually committing. And, you know, being the person I am, I decided that I want to try to put this flag on other on other commands. And I discovered I can do it on a reset. When I'm resetting files, I can actually do it with hunks. Or even when I'm checking out files. Like if I'm checking something out and I'm just like removing these changes, destroying them, I can also do it with hunks. So
-p is like it's patch.
Yeah. So I'm not exactly sure.
Log.
Yes. Yeah. I'm not entirely sure why it's called patch, and then it's like it asks you about hunks, but whatever. I don't know. Git, like I said, Git doesn't have the greatest interface at all times, so some things can be confusing or overloaded. Like I said, reset is a kind of confusing one too, because you have mixed soft and hard resets, and they're all slightly different. We can also talk about Hub. So Hub is this small utility that wraps Git and introduces it to GitHub a bit. So yeah, I think the actual description is Hub introduces Git to GitHub. And you can do things like, so once you install it, it's a small Ruby script. So you can install it as a gem, but if you're going to install it as a gem, every time you run Hub at that point, it's going to load up Ruby gems, and it's going to be very slow and painful. So it's a good idea to get it as a standalone script. If you do it with Homebrew, that's what you get. Or you can install it with curl and just download it, put it in your bin directory, call it a day. And a lot of it works really well when you alias Git to Hub. So when I use Git, yeah, let's close out of this. If I do which Git, it'll actually tell me, you're not using Git, you're using Hub. And I'm okay with that because I can still use Git like I normally would, except I get shortcuts. So if I do git clone user/repo, like let's say I want to clone linguist. So let's move back up to our temp directory. I want to clone linguist, which is an open source project that GitHub maintains for identifying files. This is what we use to figure out what file types are when we present them in the tree view. So if I want to clone this down because I'm going to work on it, I can do github/linguist, and I don't have to worry about the actual URL. I'm just like, just give me linguist. I know who owns it on GitHub, and I would like to clone it real quick.
But what's using the read-only URL or read-write URL? What's the default?
The default is the read-only URL because it assumes you don't have access to it. Now, if you do, you can add a -p flag to it, and that'll be it's saying, this is a private repo. So give me, you guys can't access GitHub, but if I were to do git clone GitHub, it would be that project doesn't exist. And then if I say GitHub, git clone -p GitHub, it's okay, yeah, that exists. Here's the rewrite URL, which is nice. So, I mean, you can use this for, what's up?
Sorry, can you use the SSL? I mean,
The HTTPS or the SSH?
The SSH.
I think it uses the SSH ones by default. I don't think it uses HTTPS links. That might have changed. I know we made the standard kind of HTTPS recently. That became the new default at GitHub. Now, we do have the sticky toggle. So it's if you pick SSH, it'll remember that you like SSH links, and that's what it'll always show you. But I think Hub is hard-coded to do always SSH.
Then you mentioned briefly why HTTPS is default over.
So we made it the default because we had a lot of questions coming in about people that had issues with firewalls to do SSH stuff, or people that were having issues with private keys. So these are two tiny things, but by doing HTTPS as the default we present to users, you're prompted for your username and password, which you already knew you set up on GitHub, and it goes over port 80, so you have less firewall problems. Or I guess 443 since it's HTTPS. And it gives you more than just cloning. You can then fork a repository. So, I have linguist here. If I did git fork, it would fork it. I already have a fork, so it might yell at me, but, if I had another project, I could do git fork, and it would fork it off to my own account, which is, I clone down some project, I can, in my terminal, type git fork, have my own fork of it, it adds it as a remote. I can, hack away and push this up and not worry. I don't have to go back to github.com to just, do these simple things. Or, I forked a project, I've pushed up some changes. You can actually issue pull requests from Hub as well. So I've definitely used this a few times, super quick. I see some crazy project, I fork it, make some changes, push it to my fork, and then issue a pull request, all in command line.
This is actually Hub, not Git, right?
Yeah. So this is assuming you've aliased. Sorry for that confusion. I didn't even think about it when I was writing these slides. Just because at this point I've internalized, Git is aliased to Hub all the time. And it's definitely most of the documentation and stuff like that, it definitely revolves around you doing that. It's not required. You don't have to do it. But because anything that you would do normally with Git will work just fine, they encourage you to alias it. Now, this is pretty much the end of the stuff I've prepared. So if you guys have any questions, that would be great. But the last kind of stuff I have is, writing a git commit without ever actually running the git commit command. So this will show you how Kenneth was talking earlier about, the porcelain and the plumbing. The two concepts of these commands that Git has, there's I think like hundreds of commands that Git actually exposes, but you don't ever have to deal with them. You usually, just sitting, using git commit, using rebase maybe, merge, stuff like that, but never, hash object or cat file. These are some crazy internals that you don't necessarily see all the time. But this all kind of revolves around Git being a key value store. You give it some information and it takes it, hashes it, and gives you back a SHA-1. And that's really all it knows. And it kind of layers these SHAs on top of each other to store metadata about this document as well. So if we give Git a blob, so if we have hash object and we give Git a tiny blob, it'll give us back a SHA. And it won't necessarily store it for us until we tell it. But I've gotten kept some commands for myself down here so that I can remember, because like I said, these are not things that you normally would do, but we can make a directory real quick for more Git playing. We'll initialize it, and then that command doesn't have any quotes. So hash object will take this little information, so what Git internally calls a blob, some information, usually text, sometimes people put binaries, totally okay as well, although Git, is not the perfect place for that, but it'll work. So what do these flags do? So normally if you give hash object something, it'll give you back the SHA, but it won't actually store anything. So if we look into our .git directory, we can see this objects folder, and if we look in there, that's where you're going to find, when things actually get placed. And there's nothing in there right now. So if we do -w, it'll actually write this blob. And standard in just says, this text is going to be coming from standard input. Normally, hash object expects you to give it a file. And it'll look inside the file, figure out what's in there, and give you back the hash for it. But so here we'll write it and do it from standard in. And we can kind of see, hey, look, we've gotten a SHA back. And if we now look into that directory, we see the beginning of that SHA in this directory. And so if we then look into 05, we can see, okay, there's the rest of the SHA. So it kind of groups the different hashes together by the first two characters of a commit SHA. And if we want to look at this thing, we don't know what it is. This is I picked up a lot of these random things from dealing with corrupt repositories. When something doesn't transfer properly to GitHub and things have broken, sometimes you have to get in there and put on some gloves and get ready and dive right into it and figure out why this repository is corrupt. So sometimes I'll see this specific SHA. It'll be like, hey, this SHA is corrupt. I'll be like, I don't know if that's a commit, I don't know if that's a tree, I don't know if that's a blob, I don't know what it is. So there's this command called cat file. And we can actually look at any Git object. So if we do cat file -p and we give it a SHA, it'll give us back, it'll pretty print us, whatever that might have in it. So if we, in another folder, move back to that merge conflict, if we look at an actual commit, it'll tell us, this is the tree, this is the parent commit, this is the metadata I know about it, here's the message. So, if you have a commit or a blob or anything, you can get some more information back from it.
But where's the change?
So that SHA doesn't specifically point to the change, it just points to the commit. A commit contains a tree, and this tree then contains our blob that we're pointing to and more information about that.
So you can basically...
So you can kind of...
file on this
So then we look at our tree, and it's like, hey, that tree has this blob. Then we get a SHA for the blob, and we can actually look inside of that. And we can see what's actually in there.
But it was packed, so it packed for us, right? So the file is kept compressed.
Yep.
So shows the content it was
Yeah, it was unpacked and shows it to us. Yep. And I think the pack files only happen, it's not always done. Because if we actually look in here, what was that, 5.4? Yeah, so you can see just like the few things we've done on this merge conflict directory. Like we've already generated quite a bit of stuff here. I guess we don't want that. We'd want less. 5.4, yeah. So yeah, you're right. It gets compressed, so it will uncompress it. I guess it stores it binary, so, you know, save some space. But yeah, it'll read it back to us in a nice fashion, so we can actually use it pretty easily. And we can also ask for the type, so -t will tell us, you know, what kind of file it is. So I don't even remember, I think this was the tree we were looking at. Yeah, so it tells us, you know, the type. So in our plumbing thing, or in our plumbing in a repository, we've put this blob in there, but Git doesn't know about it. Like if we ask git log, you know, it still doesn't know what's going on. We've only initialized this repository and then shoved some data into it. Git doesn't really know what's happening just yet. So we want to talk about some trees, because really hash object doesn't even know the file name. Like it just knows the content of a file. So we want to use update index, which will actually, you know, update our staging area, and that's how we can make a tree. All trees through Git are usually made through the index. That's kind of why the staging area exists, other than, you know, its actual use case. But conceptually or theoretically, like on the lower level, that's why it actually exists. And a random thing that you might find interesting from these, you know, this plumbing is kind of questionably useful to a lot of circumstances, but this is one command that I've found useful, where I might have some local changes to a file and it's still in the Git repository. I don't want to put it in a git ignore. This is very specific to my change. If you do update index and you say assume unchanged and you give it a file name, it'll actually never worry about that file in the staging index. It'll always pretend, you know, like that file is a clean file, which is, it can be useful.
Configuration files.
Yeah, so like that's a good one. You know, if I'm cloning down something and I make a few changes to a configuration file just to play with something, and I'm making more commits on top of it, I don't want Git to tell me about that configuration file every time. And I don't want to accidentally add it if I do git commit -a. So we're gonna update our index, and we have to, like, I'm glad I kept these shortcuts because I would never have remembered this. But so what does this actually do? So right now, this update index will add a file, as we're doing here. This file does not exist in our staging environment just yet, or our staging index just yet, so we have to add it that way. And then cache info is just saying, you know, this information doesn't exist anywhere else. We're going to feed you all the information you need to know about this. So, you know, our permissions, the content of this file, and its actual file name. So when we do, and I have that $, so
Control A.
Control A. That'll shortcut me to the front of the line.
Yeah, Control E to me.
Ah. I use the Vim, like the Vim mode in terminal, and that, I don't know. I'm very much a Vim person, so like the Emacs bindings, I never remember them.
Then 0.
Yeah, that's true. So now Git doesn't give us any information back, but if we look at our Git status, we now have, oh, I guess I'm doing this in a, oh no, because since this file doesn't exist on disk, it says, you know, you've deleted it in your working directory. Because Git assumes, you know, everything's in your working directory, but, you know, this text, or this file happens to not be. And it also says you staged, you know, greeting.txt to, you know, have something in it. So then we actually want to write this tree. So now we have our index set, and it's ready, and we want to take that current index and write it as a tree. You can even cheat off of my notes and see exactly that I'm saying the right things. But so write tree will simply take whatever our index is, write that as a tree, and give us back the SHA-1 for it. Write tree, not index. So this is a command, I don't know. I don't even know when you would actually kind of want to use this, but it's interesting to see how Git is actually working on the lower levels. But so now we have a tree and we have a SHA for it. So now we can actually make our commit. Like we have not even made a commit yet. If we, do git log, it's still going to tell us, I have no idea what you're talking about. If we do git status, it's going to be like, okay, you have this file staged and everything, but still nothing's committed. We've just written a tree that represents our staging area. So I think it is write commit or commit tree. Okay, cool. So once we run that, so it takes from standard in a message and takes a SHA of what tree it's actually going to commit, and then gives us back a SHA of our commit. So now we can kind of look at this, and we can actually see we have a commit here finally. It says initial commit, it's got a diff for us. We went from having no file, we added this greeting.txt. Fantastic, we're actually getting some progress here. Now if we do git log, it still has no idea what we're talking about. So we have to tell Git that our head, the head, which is what points to the very tip of a branch, that this is actually referring to that commit. Now refs like that are stored as plain text, so I think we can do into .git refs heads master, because we're going to be working on the master branch, and then we do git log. Finally we have a commit. Wonderful. So through all that pain and struggling, that's how Git kind of does it under the covers.
Mind blowing.
And write tree or commit tree will also take a command of -p for parent. So that's how they get linked down, and you can give it multiple, and that's how merges are formed. You give it multiple parents and it knows it's a merge commit. So we can go through and do this all over again, and have a second actual commit to point to if you guys really want. Do you guys have any questions or thoughts on
Commands use this?
Yeah.
Is there a way to see
see as they're doing that? I don't think so. No. That would be really cool to do git commit and you see each of the different steps.
Verbose or
I mean, so let's check out, and that should actually give us our file. So now we've actually written a file. So we never actually wrote that on our file system, but doing that checkout gets like, you didn't mean to delete that file, let me put it back for you. We've kind of tricked it. So we've written this file. Let's go ahead and change it and see if we do git commit -verbose, what'll happen. I guess I have to add it first, of course. No, nothing more useful. So Git commands can be kind of sometimes, I know I had a few stumbling blocks when I was looking up man pages for commits or commands when I was first starting to use Git, because they're all two words, right? If you do man git commit, it's like, well, here's Git, and then I don't know what you're talking about for commit. It thinks you're trying to look up two different things, because you could do, man for CD and ls, and it'll look up these two things separately. It'll show up each of them. Now,
there are man pages for individual subcommands, though, right?
Yep. So you can do two different things. You can either attach them via dashes, and you'll look up the actual command, or you can just ask Git for help. So Git help and any of the subpages or subcommands will give you the man page for it. So let's see.
Oh, there's a -v. I wonder what that does.
So so the output of the diff, if you normally type git commit, it'll have the first line, and then the rest of it will be commented out. So it looks like, here, let's make another change. course, I have to add it. So this time, it did not comment those out. So it makes your message more verbose. So you can actually see the diff inside of your commit message. Like, I mean, normally it attaches that, but it's all commented out. Now, by default, it's going to try to commit with that message there. I don't know. I don't think that's all too useful because that's pretty much all the data the commit contains. But, I don't know. Could be useful, maybe. Oh, but it's still considered it empty. Huh. So I guess you can't actually commit with that message. But it shows you the full commit diff inside of the message, or as part of it. So when you're writing your message, maybe you can see some more details about the diff you made if you didn't know for some reason. Any other questions?
If I've made a lot of commits,
Yeah.
I want to see all the files that I've changed.
Over all of those commits? So, let's see. I think you can do stat.
If you do git diff -- stat and then the first commit or range of commits, it'll put the stat together.
Cool.
So like head, tilde, whatever, or yeah, something like that.
All right. So that would be the way. So git diff will show you the actual differences between like things that have happened. And if you do -stat, it shortcuts it and gives you the statistics about it. You know, just the additions and subtractions. And so then you can give it a range of commits and it'll read them out to you. Thanks, Daniel. Any other questions, thoughts, concerns? I don't know how much time I've eaten up and how much time I actually still have, but I can answer anything. Did anyone issue any pull requests against that that page? Or does the internet so spotty we can't do that? I know Daniel posted one because I asked him to.
There seems to be a line for stuff you do locally that you won't push.
Yeah.
So what would be your guidelines for what kind of changes should be made only locally?
Okay, so the main thing is when you rewrite history. So anything, like once you've made a SHA and it's been pushed up, I no longer want to play with those things. I want to leave those by themselves. Now, when I would push a thing locally or when I would push it, depends on the project I'm working on. Like, you know, a lot of the stuff I work on for GitHub, I push it immediately because we don't really worry about what our history looks like. And on top of that, I'm more concerned that my laptop's going to explode, or, you know, like I've worked at GitHub for like 8 or 9 months now, and I've gone through like 4 laptops. Not because I've broken them, but, you know, this one I got one laptop and that was just a loaner. It wasn't working very well. It got replaced, fine. I get another laptop and the screen was broken, or like the screen had really bad ghosting problems. So then I sent that in for repair and I was using another one in the meantime. Like, I don't want my machine to be the end all be all. I would rather that information live somewhere else too. So I try to push that up all the time. But other things that I've worked on for myself, you know, I don't push it up, and then, you know, I have to take the risk of, you know, if I dunk my laptop in water, I might not be able to get that data back.
So do you push rebases and squashes and stuff like
so
that?
Those, so that ultimately comes down to how your team works. GitHub doesn't do like much history alteration, and that's because the main thing we don't want to add is friction between like cloning down changes. Now in the past, I have used rebases and stuff, and that's when it's trickier because I have to communicate with the people that are also working on that they have to delete their changes and they have to clone down again. So if it's something really important, like if you're removing sensitive credentials from a Git repository and you have to alter your history to make sure that they're not anywhere in the history using filter branch, then I would do a force push and I would tell everyone, like, look guys, I'm sorry, but you're gonna have to delete your stuff and just reclone. So I don't know, it comes down to how much you want to have to interact with the other people and tell them, you know, these things have changed versus how much you value the actual history you have and what you want to keep. Any other questions?
There's this GitHub for as a service. I mean,
GitHub as a service?
yeah,
What do you mean?
a paid service, right?
Enterprise.
Enterprise
Yeah. Oh, yeah.
for groups.
Yeah. Enterprise.
Private GitHub.
Yeah. So I actually work on some of the enterprise team stuff. But yeah, what about it?
That's what used to be GitHub Firewall.
So it used to be firewall. So you get to see the staff view now. But
Ooh, client.
so yeah, it used to be firewall. Firewall was packaged very differently. Firewall was a package you could install on your machine. Enterprise is a virtual machine that we ship you an image, and you have to boot this virtual machine. What kind of questions do you have about it?
Basically, I asked my current gig, why don't we use GitHub Enterprise or GitHub for workgroups or something like that?
Yeah.
And they said, well, it's distributed. There's no point in doing that. We just keep it on some server, and if it dies, nobody cares because it's everywhere, right?
Okay. I mean, so that's true if you're using just a Git instance anywhere.
Yeah.
But the value of GitHub Enterprise is the things that GitHub does on top of Git.
Like what?
Well, so like the pull requests. Like pull requests are not part of core Git, especially with the interface that we have and like the inline comments and stuff like that. So people that really value that kind of stuff and want it internally, that's the kind of people that come to GitHub Enterprise. So you have to convince, if you're trying to convince them, it's not just about Git itself, it's about the things that GitHub does on top of it.
Issue management.
Yeah, like issues, that's a good one, or the documentation we keep, stuff like that. Any other?
I actually do have one.
Yeah.
It's not really related. So
That's fine.
Let's say you fork someone's repository.
Yep.
And then some time passes. They continue working, and then you suddenly remember that you forked it. Now you want to do some work. How can you sort of pull the latest changes on GitHub for that fork? I mean, you fork.
So you want to take your fork and forward it up?
Yeah.
So I mean, the easiest way is
Clone it, do it yourself.
no. I mean, in your so here we can kind of emulate this or talk about it here. Like this is not like we don't provide a button for this or anything on GitHub, but what you can do is if you have them both as remotes, you can just take the other remote and just pull from that. So you can get
into your.
Yeah. So
Oh, okay.
say you have a fork, so your origin points to your fork of it,
Right.
and you can add another remote that points to the original, and you can do git pull, original master,
Right.
and it'll pull all the changes from the master branch of that original repo.
Yeah, but then those changes are pulled locally to your machine.
Then you can push up back to your fork, and everything's in sync.
But I'm usually rebasing. I'm doing the page and rebasing.
Yeah. So if you're rebasing a lot, you can do git pull -- rebase, and that will automatically rebase as you're pulling. So whatever changes you have will be it'll take those changes, put them off to the side, pull the changes from the other branch, and then layer your changes back on top.
Yeah.
So it'll do a rebase for you. And if you do this all the time, you can actually set this. I think it's a config.auto rebase. So you can do git config global auto rebase equal 1, I think, or auto rebase true.
Maybe you can discuss a bit about this rebase versus not rebase issue.
Hmm?
What's your experience about? I think we discussed yesterday about rebasing versus not rebasing versus pooling on seeing the history of all the merges or not seeing the history of all the merges. How you went through this?
So yeah, rebasing has the advantage of having a cleaner history, and some people really value that. Whereas merges, it's a nastier history, but on the other hand, you don't have to worry about people not being able to clone things down. So I like rebase if I'm just doing local things, like I'm about to push up a branch, and I realize that master has moved quite a bit. So I'll pull master in and do a rebase, so that way my branch starts off of the tip of master versus somewhere in the back. Now, like I said, this is before I've ever pushed it. So if I've already pushed it, then I'm just gonna do a merge. Just because if someone else has cloned down that branch, I don't want to inconvenience them. But like I said, it ultimately depends on how your workflow works. So I know in the past I used to rebase a lot more often because I worked in a consultancy, and one of the things we did was every week you were assigned another developer that was on a different project, and you looked through his code for the week. And you look through their code, and if it was filled with merge conflict or like merges, you would open up like a bunch of these different merges and you're like, why am I looking at these changes? I don't necessarily care about it. I only want to see the commits that don't have merges. So then there's more of a pain of like having to filter out the merges. You can do that with Git log easily, but I wanted to always open it up in GitHub. And then I had to find like, how can I look through the history on GitHub without seeing the merges? And it was, sometimes there were commits that were in multiple places. So we would usually rebase. And we rebase just to have a clean history, because when you look back on a week of commits, it's nice to have something clean that you can deal with. At GitHub, we do most of our review, like code review kind of stuff in pull requests as we're working on them.
Next question, yeah.
And so we don't really worry about merges too much, because as long as it's in the pull request and you can read it there, that's fine. That's all we really need.
So actually, the way you work, you fork the GitHub sources, you push it to your own private repo, and then you send a pull request. You don't push it to the GitHub, right?
Yeah, so it's actually kind of an interesting way that GitHub works for that. So it's very much like an open source project that's all private. So when you start working at GitHub, usually what happens is like github.com code base, you'll fork it to yourself and you'll work there. But if you're working on github.com all the time, then eventually you just push branches to GitHub. Like, you don't have to worry about using your own fork. You can just push another branch and pull request locally, that branch onto master. So it depends on if you work on a thing often enough, or it also depends on the size of the project. So like smaller projects, we don't worry about forking a thing too often. We can just, work in branches on that one actual repository.
But you mentioned sending pull request when you merge branches.
Yeah.
How do you do that?
So you don't always have to fork a repository to send a pull request. If you have two different branches, let me see. I think I have some branches in this. So this is a Vim plugin I wrote. Do I have any branches? So yeah, there's some. Cool. You can send a pull request.
All right, the destination, you can choose the destination.
So you can choose, we don't want the branch to be that. We want it to be
From yourself to yourself.
Yep. Now, master's already merged this in a long time ago. This is some stale branch, but you get the idea that, you can do it from any branch. It doesn't have to be, a different actual repository.
Not last question. Why is the compare is not so easily accessible from the UI? Because I know there is a GitHub/compare.
Yeah. The compare links are really nice.
I learned it someplace. I have it put in my notes, but I never find it.
So another nicety of Hub is it makes compare links pretty easy to get to. It gives you a git compare that will open up GitHub.
Why just to put it into the application so people can click on it?
We haven't found a good place to put it yet. I don't know. GitHub is, it's more of like no one's been passionate enough to put in a button for it or anything. We don't use the compare button that often, so it's not a pain point we feel. I definitely understand. Like, I don't know, I've used it in the past before I started working at GitHub, and now I work at GitHub and I haven't used it in quite a while. So it's one of those kind of strange things. I'm glad it exists, but I don't even know where a button would necessarily go for it as well. Like, we have the mantra of, everything we add to the web page makes everything else less important. So if there was some, 500 extra buttons here, suddenly everything on the page is much less important because there's just so much more of it. So, we try to keep things as simple as possible because we want to put only the most important things on a page.
Thank you.
Yeah. Any other questions, thoughts, comments? Was this useful to you guys?
Very useful. Yeah.
Awesome.
The Hub thing, I wasn't aware of this.
Yeah, Hub is a really awesome tool.
There's also the Git flow.
Yeah, so someone was actually asking me about Git flow earlier. I'm honestly not a fan. I don't think that you need that kind of rigidity, but some people do, and it works out well.
It's like batch commands for Git. Like, it creates features. I mean, it's Git, so it's not necessarily something different, but you just create, puts in some sort of workflow. You start working on a feature, the feature prefix.
I also really don't like, it does the branches with like feature / other things, yeah.
Well,
I don't know.
There's one advantage to that. If you use a continuous integration server like TeamCity, so it has a notion of not like a pre-tested commit, but pre-tested pre-tested commit. A private build. You can specify a prefix to a feature name, to feature names, and then every time you push that feature with the prefix, it will make a personal build. So you can actually kind of push it and make sure it works remotely before you.
So I like the idea of prefix branches. I just really dislike the idea of having a slash in a branch name.
Oh, you can totally.
You can configure it, but I don't know. Like, it's a default that really, like, I don't know. It's like grading fingernails on a chalkboard. Like, I see it and I'm like,
I
ugh.
just had this very certain flow in mind when they created.
Yeah. And everyone has a different, like I said, you know, Git's a interesting tool that allows you to construct your own version control workflow out of what the tools it provides you. And Git flow is one of those. It's just never been, for me, something that's too appealing. So, you know, if it works for you, fantastic. If it doesn't, you can construct your own workflow, right? Yeah, it's whatever.
I'm going
It's
to
good.
Git flow in 2 days.
Oh, right on.
There's a reversing summit.
Okay.
Cool.
See you there.
I will talk about Git flow.
Awesome. Yeah, like I said, I don't know. I think Git is a fantastic tool, and if Git flow is the one that, you know, works with how you work, then fantastic. Go with it. I don't know. As long as you're versioning things and, you know, getting the diff and, you know,
So here's an idea.
merge
Maybe
ideas,
you
then
want to make a list of tools like the Hub or Git flow, Git related tools that we recommend as like GitHubbers. So
yeah.
people will know them.
I mean, the main one that I would use is Hub, and I think there's
You know if it's possible to install on the Windows Git?
Hub. Yeah, it should be. It's a Ruby script, so
Just a bunch of scripts. So.
yeah. I think if you, so I mean, it's a giant list of things, but yeah, it's just it's a little Ruby app, and it's kind of meant to normally use system Ruby for OS 10, but I wouldn't see any problem with it running on, you know, 187 on Windows either. Yeah. And there's, if you found it interesting, there's so many more commands it does, so I would recommend it. Yeah, I think the homepage lists a lot more. And I mean, so Hub is an interesting thing that we've now, by default, gets installed on GitHub machines. And I think most of our employees don't know this. Like, I don't know that they actually know about Hub either. But
It's just there.
you have Hub.
I have Hub on my laptop. I've never used it.
Yeah, exactly.
Know that it was on my laptop until you told
Maybe
me.
you should. Maybe
Exactly. Like, these things kind of sneak out. And
Maybe you should alias it by default. Like you
no, we do.
Oh.
We have.
They use Hub.
They use Hub. They don't even know it. Yeah.
Because they still use their regular Git.
Yeah,
flow,
it's
so
just Git, normal Git commands, and it's just like people like me. I'm like, I know that I already have Hub. I'm just gonna take advantage of the shortcuts.